fun part. This is where we take everything we just learned in a video, little pieces, and we put all the pieces together. So this is probably the most important thing that you'll learn in this course, is how to determine and find exact trig values. So here are the steps. I wrote them out. First thing you want to do is determine the quadrant that theta lies in. And that means that if I am looking at an angle that's bigger than 360 or less than 0, so if it's not between 0 and 360, you need to find the coterminal angle. And we've already talked about how we do that. So make sure that the angle you're looking at is between 0 and 360. Then you find the reference angle. The reference angle is just going to be the acute angle associated with the x-axis. You find the exact value of the reference angle. That's always going to go back to the chart. So the chart we filled in when we looked at 30, 45, 60, and then we looked at the quadrantals. That's the chart you have to know. So everything is going to go back to some value on that chart. So if you haven't already learned it, you need to learn it. And then the fourth step, the last step you need to do, is make sure you find that you use the correct sign based on whatever quadrant your angle is in. And remember, we just did all seniors take calculus for that. Alright, so let's go ahead and do some exercises here. Number 14 from 6.3 asks me to find the exact value of the sine of 240 degrees. So if I'm looking at this, I'm probably going to just go through the steps. So first step, what quadrant does theta lie in? Well, if I'm looking at that, I know that the second quadrant, we go from 90 to 180. The third quadrant is from 180 to 270. So ding, 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 ding. I'm in the third quadrant. Okay. Then I want to find the reference angle, and maybe I will just kind of draw this out so you can visualize it. Alright, so here I am over here in this quadrant right here, and so to find the reference angle, I'm doing theta minus 180. Alright, so I'm just doing 240 minus 180, which is 60 degrees. Okay, so that's my reference angle. My reference angle is 60 degrees, and in this particular problem it asks me for the sine. So I want to know what the sine of 60 degrees is. Well, at this point, if you haven't memorized that chart, look back at the chart and find sine of 60 degrees. The sine of 60 degrees is the square root of 3 over 2. But I'm not quite finished yet because I have to make sure I use the correct sign for sine in the third quadrant. Now remember that tangent and cotangent are the two positive trig ratios in the third quadrant, which means sine in the third quadrant is negative. So my final answer is going to be negative square root of 3 over 2. Okay, let's do another one. Cosine of 600 degrees. 600 degrees is not between 0 and 360, so I'm going to find a coterminal angle here. Alright, so let's just, to find a coterminal angle, remember we just subtract one revolution. So I subtract 360. That means I'm looking at the cosine, or coterminal angle, so I'm looking at the cosine of 240 degrees. Where's 240 degrees? 240 degrees, we just did that over here. We know this is in quadrant 3. Alright, so I'm in quadrant 3. My reference angle is 60 degrees. I already determined that because I did 240 minus 180. This time, instead of looking for the sine of 60 degrees, I'm looking for the cosine of 60 degrees. And the cosine of 60 degrees, you look back at your chart, or if you already know it, is 1/2. And cosine in the third quadrant is negative. So my final answer is going to be negative 1/2. Okay? Alright, so let's do secant of 7 pi over 6. Alright, quadrant is this going to be in? I don't know why I picked problems, but it seems like all our problems are coming from the third quadrant. So 6 pi over 6, right there we are. And like I said, you could change this to degrees if you're more comfortable with that. But we're looking at quadrant 3. My reference angle, if you don't change that to degrees and then subtract theta minus 180, remember that we're doing 7 pi over 6 minus pi, which in this case is going to be 6 pi over 6. So my reference angle in this case is going to be pi over 6. Now I'll go ahead and tell you a little secret. If you are given your angle in radians, your reference angle is always going to be pi over whatever that denominator is. Okay? So our reference angles are always going to go, if it's not a quadrantal, if it doesn't lie on one of these axes, it's always going to go back to 30, 45, or 60. Okay? So whatever our denominator is, that's going to be my reference angle. So my reference angle is pi over 6, or 30 degrees. So I'm looking for the secant of pi over 6, which is actually 2 square root 3 over 3. And then final step, secant is negative in this third quadrant. So my final answer is going to be negative 2 square root 3 over 3. Okay, one more problem from that section just to make sure you understand what they're asking for. They want you to find all 6 trig ratios, and they give you that the tangent of theta is 4 over 3. They also give you that theta is in quadrant 3. Alright, so this isn't any different than what we did in an earlier section. And I'm going to go ahead, and I always do this, and I would recommend you doing the same. I always draw a right triangle and then label my sides. So remember, this is my opposite, this is my adjacent, and that's what tangent is. So I've got opposite over adjacent. And if you don't recognize that this is a 3, 4, 5 triangle, you need to use the Pythagorean theorem to find that third side. But this is important at this point because unlike what we did previously, everything was positive. This is telling me that my theta is in quadrant 3, which means the only positive trig ratios are going to be the tangent of theta and the cotangent of theta. So if I'm looking for all 6 trig ratios, in the third quadrant, sine is negative. Well, what's sine? Opposite over hypotenuse, and it's going to be negative. Cosine is adjacent over hypotenuse, and it's going to be negative. And then tangent they gave us was 4 over 3. And then I'm going to also find the reciprocals. So just note that these are the only 2 that are positive.